Hello, welcome to our video. Today we will be discussing limits and the properties they possess.
The first property we will be discussing is the limit of a constant. As x approaches a of a constant, the limit equals that constant. For example, if a function is f of x equals 3, the limit as x approaches any number, for example 2, will always equal 3 because the function equals 3 no matter what the x value approaches.
One simple way to evaluate a limit is just by plugging in. Therefore, the limit as x approaches a of x is equal to a, which you get from just plugging in a for x. For example, if you had the problem, the limit as x approaches 3 of x, you would just plug in 3 for x, so the answer is 3. Most problems are more complex than this, but it is important to be able to use this rule because it may be used along with some of the other rules in the future.
So next we have the constant multiple rule, which is a pretty simple rule, but it can be very helpful when simplifying your problems. So the rule states that the limit as x approaches a of a constant times a function is equal to the constant times the limit as x approaches a of the function. So basically you just pull out the constant in front and multiply it by the limit of the function. Let's take a look at an example. Here we have the limit as x approaches 0 of 5 sine 3x over x. So first what we can do is pull out the constant 5 and put that in front and multiply it times the limit as x approaches 0 of the rest. Then we have sine 3x over x. Now this seems similar to sine x over x, which is a very important property to remember in AP Calculus, because the limit as x approaches 0 of sine x over x is equal to 1. But since we don't have that, we need to multiply that portion of the problem by 3 over 3. And then we get 5 times the limit as x approaches 0 of 3 sine 3x over 3x. Now we have another constant that we can pull out using the constant multiple rule, so we put the 3 out in front and multiply it times the 5 times the limit. So now we have the limit as x approaches 0 of sine 3x over 3x. And this is basically the same general idea as the limit as x approaches 0 of sine x over x. So this limit is going to be equal to 1. Next we have 5 times 3 times 1, which is equal to 15.
The next two rules go hand in hand, the sum and difference rules. Basically, if you have the limit of the sum of two functions or the limit of the difference of two functions, you can separate the functions and take the limits of each, then either add or subtract those. For example, if you had the limit as x approaches 5 of x squared plus 2x plus 3, you can split it into the limit as x approaches 5 of x squared plus the limit as x approaches 5 of 2x plus the limit as x approaches 5 of 3. The answer to this, 25 plus 10 plus 3, which is 38, is the answer to the problem. The same holds true for the difference rule, except you would be subtracting the individual limits.
Next we have product rule, and this rule states that the limit as x approaches a of f of x times g of x, two separate functions, is equal to the product of their individual limits. So the limit as x approaches a of f of x times the limit as x approaches a of g of x. So let's look at an example. The limit as x approaches 5 of x times x plus 2. So what we do is we split apart the limits and multiply them together. So the limit as x approaches 5 of x times the limit as x approaches 5 of x plus 2. Then you take the concept of plugging in and you just get 5 times 5 plus 2, which is equal to 35. So very similar to the product rule is the quotient rule. And the quotient rule basically says if you have the limit of a function over a second function, then you can take their individual limits and divide the limit of the first function by the limit of the second function. But this is only true if the limit of the second function is not equal to 0, because you can't have an undefined answer. So let's look at an example. The limit as x approaches 2 of x squared over x. So x squared and x are both individual functions, so what we can do is take their individual limits. So do the limit as x approaches 2 of x squared over the limit as x approaches 2 of x. Then we can just plug in 2 squared over 2 equals 4 over 2 equals 2.
The next rule we will discuss is the power rule. This rule states that as x approaches a of f of x to the n being any real numbered power, equals the limit as x approaches a of f of x to that power.
For example, the limit as x approaches 2 of x cubed equals the limit as x approaches 2 of x cubed. The limit as x approaches 2 of x cubed equals 8, and the limit as x approaches 2 of x equals 2, and that cubed equals 8. Most of these rules are pretty easy to follow, and knowing these rules will definitely help you on more advanced problems.
So when you're solving a limit, always try to plug in first. That's definitely the simplest way to solve a limit. But remember though that if you plug in and you get an indeterminate form, like 0 over 0 or infinity over infinity, you're going to have to try another method like L'Hopital's rule, factoring and canceling, or multiplying by the conjugate. On the AP test, you're likely not going to see many or any at all, which you can just plug in. So knowing all these properties of limits that we mentioned in this video will definitely be helpful to simplify before moving on to other methods.
Thanks for watching, and we hope this helped.